Developers using GitHub Copilot completed a coding task 55.8% faster. AI made them 19% slower. Early 2025 AI tools, they took 19% longer. Only 3.9% of professional developers said AI handled them very well. But reviewer workload roughly doubled and automated review eventually overtook human review. Generating more code into a bottleneck is not productivity, it is accelerated queuing. Everybody says AI makes developers faster, but the evidence says something much more interesting. In one controlled experiment, developers using GitHub Copilot completed a coding task 55.8% faster. Across 3 company field experiments involving 4,867 developers, access to AI-assisted increased completed tasks by 26.08%. At ANZ Bank, developers in controlled challenges finished 42.36% faster than METR studied experienced open source developers working inside repositories they already knew, and AI made them 19% slower. Those are all real results. So who is wrong? Probably nobody. The studies measure different kinds of work, and that exposes the biggest misunderstanding in this debate. AI improves local coding speed far more reliably than it improves end-to-end software productivity. GitHub's control study recruited 95 professional developers and asked them to build a JavaScript HTTP server. The Copilot group completed the task 55.8% faster. That is a major gain, but notice the environment. One clearly defined task, a clean starting point, and an output that could be checked quickly. A much larger set of randomized field experiments produced a smaller but still meaningful result. Researchers studied 4,867 developers at Microsoft, Accenture, and a Fortune 100 company. Developers given an AI coding assistant completed 26.08% more tasks with a standard error of 10.3 percentage point. Less experienced developers generally adopted the tool more. ANZ Bank also reported a 42.36% reduction in completion time across 172 usable observations from controlled Python challenges. Average time fell from 30.98 minutes without Copilot to 17.86% minutes with it. Beginners improved by 52.27%, intermediate developers by 41.6%, and advanced developers by 40.48%. The Copilot group also showed fewer bugs and code smells. Its unit test success ratio was 12.86% higher, although that particular difference was not statistically significant and the security results were inconclusive. But that study has an important limitation. It used algorithmic exercises and self-reported completion times, not months of work inside a production codebase. The data is not saying every engineering team becomes 40% more productive. It is saying that when a task is bounded, familiar, and easy to verify, AI can produce a large speedup. A 2026 meta-analysis preprint combined 23 programming studies and found a moderate overall productivity gain, a Hedges G of 0.33 with a 95% confidence interval from 0.09 to 0.58. That is evidence of a real average benefit, but nowhere near evidence for a universal 2 times or 10 times effect. The results also varied substantially. Controlled studies generally produced larger gains than open source at enterprise settings. That gap is the story. METR tested a much harder environment. 16 experienced open source developers worked on a 246 real issues inside mature repositories where they had an average of about 5 years of experience. This was not a toy benchmark. These developers knew the code bases, understood the architecture, and were solving real maintenance tasks. With early 2025 AI tools, they took 19% longer. Even more revealing, before the experiment, they predicted AI would make them 24% faster. After completing the work, they still believed it had made them approximately 20% faster, even though the measured result showed a slowdown. That is a perception gap of roughly 39 percentage points between what developers thought happened and what the experiment measured. why the AI could generate code quickly, but developers still had to prompt it, wait for it, inspect its output, correct near misses, and recover from changes that appeared plausible but did not fit the repository. The AI generated code quickly. Verification absorbed the savings. That pattern also appears in developer sentiment. Stack Overflow's 2025 survey found that 84% of respondents were using or planning to use AI tools, but 46% distrusted the accuracy of AI output, compared with only 33% who trusted it. Just 3.1% said they highly trusted it for complex tasks. Only 3.9% of professional developers said AI handled them very well, while 41.4% rated its performance bad or very poor. Adoption is high, confidence is not, and realistic benchmarks show why. SW Lenso used more than 1,400 real freelance software engineering tasks worth approximately $1 million in actual payouts. At publication, frontier models still fare the majority of those tasks. DORA's 2024 research found AI adoption was associated with better individual productivity, flow, and job satisfaction, but also with worse software delivery, throughput, and stability. DORA's 2025 conclusion was very clear. AI acts as an amplifier. Strong systems can convert faster coding into faster delivery. Weak systems convert into more work in progress and more review pressure and more instability. A July 2026 longitudinal enterprise preprint makes that bottleneck visible. Researchers followed 802 developers and analyzed 196,212 pull requests from January 2024 through April 2026. By the end of the study, per developer throughput had risen to 2.09 times the pre-mandate baseline, but reviewer workload roughly doubled, and automated review eventually overtook human review. Merge and revert rates remained stable, suggesting the organization absorbed the extra output but only by expanding the verification system around it. Because AI adoption was not randomized, the study cannot prove AI caused the full 2.09 times increase, but it shows what happens when code creation accelerates. The constant moves downstream. A separate open source study found a similar redistribution of work following Copilot's introduction. Less experienced developers produced more output, but core developers reviewed 6.5% more code, while their productivity in writing original code fell 19%. So one developer's speedup can become another developer's review queue. The bottleneck moves from typing to reviewing, from drafting to testing, from generating a change to proving the change is safe. That gives us the cleanest line in this entire debate. Generating more code into a bottleneck is not productivity, it is accelerated queuing. The unit of productivity is not lines of code, it is reliable, useful change delivered with acceptable review and maintenance cost. There is one more metric most productivity claims ignore: learning. In a randomized experiment, 52 developers learned an unfamiliar Python library. Half could use an AI assistant, half could not. The AI group did not achieve a statistically significant improvement in task completion time, but on a follow-up test, they scored 17% lower or 4.15 points lower on a 27-point quiz. The effect size was larger. Cohen's t was 0.738 with the p-value of 0.01. The largest weakness appeared in conceptual understanding, code reading, and debugging. That does not prove AI always harms learning. In fact, the 2026 meta-analysis found no statistically significant overall learning effect across the available studies. Its Hedges G was 0.14 and the 95% confidence interval ranged from negative 0.18 to positive 0.47. In statistical terms, the current aggregate evidence cannot confidently distinguish a small learning benefit from a small learning cost. but the randomized experiment shows a real risk. AI can help someone produce an answer without helping them build the mental model required to verify it later. For junior developers, especially, short-term output and long-term capability must be measured separately. So, does AI make developers more productive? The statistically honest answer is sometimes dramatically, sometimes moderately, and sometimes not at all. The strongest gain appears in tasks that are well defined, repetitive, reversible, and easy to test. Boilerplate, documentation, scaffolding, routine transformation, simple tests, code explanation, and first drafts. The weakest results appear when work is ambiguous, tightly coupled, legacy heavy, security sensitive, or dependent on deep repository knowledge. And the average result hides enormous variation. A control task can show 55.8% speed up. A large company experiment can show 26.08% more completed tasks. A real repository trial can show a 19% slowdown. All three can be true because they measure different points in the software development system. Teams should stop measuring only how quickly was the code written, measure 5 things instead. Time to first working draft, time to review and merge change, defect, revert and incident rates, reviewer and maintenance workload, and whether the developer can explain and debug the result without the model. That is the difference between local speed and real productivity. AI makes code cheaper. It does not automatically make engineering faster. The winning developer is not the person who refuses AI, and it is not the person who accepts every suggestion. It is the person who knows which work to delegate and how much verification that work requires, and when using AI would replace the exact thinking, they still need to learn. So AI productivity is real. The universal 10x developer claim is not. The evidence is not contradictory. It is measuring different layers: generation, completion, review, delivery, stability, and learning. And once companies confuse those layers, they also start misunderstanding which developers they need to hire. This is the next myth, the AI job myth.